So guys, we will be continuing with the second part of the lesson, which is rate of a chemical reaction. So first thing we're going to start with is the definition of the word rate. When you hear the word rate means simply speed. So the speed of the chemical reaction is the rate. It is important to study rates of reactions to know how fast or how slow the reaction would go. In industrial processes, for example, this affects cost a lot. Check out these three pictures that you have here. For example, rusting. Rusting is a slow process. It takes time to happen. Baking, this is fast. You can bake cookies, you can bake anything you want really fast. Explosions. You see this explosion from fireworks? It's very fast. It takes few seconds just to explode. So there are differences between slow and fast reactions. Now, as you can see here, this is rusting, which is a slow chemical reaction. It takes place very slowly. Wood burning, it's a chemical reaction with a fast rate. So this has higher speed than rusting. Take a look at these pictures. I want you to think which of these are fast and which are slow chemical reactions. Well, it's relative, so I'll just check a few examples. For example, chocolate melting. This is a fast process. It happens by the action of temperature. Burning, it's a fast process. Firework explosion, it's a fast process. Baking, it's relatively fast. Rusting, slow. Boiling, also it's fast. Melting of these ice or candies, this is fast. Rotting is slow, takes time. So whatever the case, you have differences between fast and slow chemical reactions. Now, for the factors that affect the rate. In chemical reactions, there are four main factors that affect the speed or the rate of the chemical reaction. We have surface area, temperature, concentration, and the presence of a catalyst or inhibitor. Let's check. Number one, surface area. Let's compare these two pictures. What's the difference between the two? Is that one of them has smaller pieces of charcoal. When you have smaller pieces of charcoal, it means you have a larger surface area. Why? Because the small pieces can be exposed from all the sides, all around. When smaller pieces are used, cooking can be a lot faster. So smaller pieces leads to more surface area, so greater rate, increased rate of reaction. It will be faster. Let's check another example. Now, you compare these two pictures of chicken. The difference is that this one is 1 unit, and these are smaller pieces. Which one of these has larger surface area? The small pieces, because they can be the heat can be absorbed from all sides, from up, left, down, right, and you have many of them. So this one has larger surface area. This is very simple. So when you have larger surface area, they cook faster. That's why small pieces finish faster than one big piece, because they have larger surface area. So for the first factor, if you increase the surface area, the rate will increase. Second, this is temperature. Increasing the temperature will allow reactants to get over the activation barrier more quickly, thus increasing the reaction rate. This means that if you provide enough temperature, or you increase the temperature of a certain reaction, it will be faster to reach the activation energy, and you will have a higher rate. Now, the opposite, what happens if you decrease the temperature? The reaction will slow down. So if you increase the temperature, reaction will go faster. If you decrease the temperature, reaction will slow down. Let's take an example. Why do we preserve food or store food in the refrigerator? Because the low temperature in the refrigerator will slow down the rotting or the decay of food by bacteria and microorganisms. So the food lasts longer. That's why you store it at lower temperatures. So for number 2, which is temperature, increasing temperature leads to higher rate. Decreasing temperature leads to slower rate. Third, concentration. Now, before we talk about the factor itself, we need to define concentration. Concentration is the amount of a substance in a given volume. That's the amount. So, for example, if I'm making tea and I put enough sugar, if I add more sugar, the concentration of the sugar in the tea would increase. So the amount would increase. Okay, so what happens if I increase the amount? If I increase the amount, which leads to higher concentration, it means that you will have more reactants. More reactants means more collision. They will collide more. They will bump into each other more. They will come closer and into contact with each other and collide. Whenever they collide, bump into each other, the chemical reaction happens. So if you have more reactants, you will have a higher rate of a chemical reaction. So concentration is our third factor. If we increase the concentration, the rate would increase. Number 4, catalysts and inhibitors. Pay attention to catalysts, it's really important. A catalyst is a substance we put for a chemical reaction just to increase the rate. That's it. Just to increase the rate. It's not actually considered a reactant. It's a substance added to the reaction. What does it do? It increases the rate. It makes the reaction faster. How does it do that? The catalyst acts by lowering the activation energy. If you look at this graph, you have reactants, you have products. This is an exothermic reaction. How did I know? Because the energy of the products is lower than the energy of reactants. You see it's under it. So energy of products is lower than reactants. So this is an exothermic reaction. Now let's check the activation energy. The energy required for the reactants to form the activation complex right here. This is the activation energy without the catalyst. The blue pathway is the energy without the catalyst, the normal reaction energy without using a catalyst. If we put a catalyst, a chemical, a substance, what does it do? If you notice that you will have a different pathway, a faster one. So you reach the activated complex faster than the case without the catalyst. So what's the role of the catalyst? It lowers or decreases the activation energy in such a way to have a faster reaction. So we reach the products faster. Now, what happens to the catalyst throughout the reaction? The catalyst is not changed itself. So for example, if I'm having a reaction and I put, let's say, this is just an example. Let's say I put 2 grams of the catalyst. At the end of the reaction, after the catalyst has worked, I can recollect the catalyst. I can use it again and again and keep using it for a long period of time, sometimes for years. So this is the thing about catalyst that makes it very special, is that it is not permanently changed, so you can recollect it. So to sum up, a catalyst is a substance that lowers the activation energy and increases the rate of the reaction, and it does not change or participate actually in the reaction itself. It just increases the rate. Now let's take an example of catalyst. A typical example would be enzymes. I'm sure in biology you have heard about enzymes. Enzymes help reactions happen in the body at normal body temperature. Let's check what enzymes do. So if you look at this picture, these are your 2 substrates. Now substrates for us are the reactants. So these are the 2 reactants, the yellow and the blue. They need to react with each other. They can do that normally and give the product. It will take a lot of time. What does the catalyst do, or the enzyme in this case? Here comes the enzyme. It has certain locks for the substrate to attach onto. So the reactants or the substrates attach onto the active sites of the enzyme, and then the enzyme helps break and make new bonds and releases them as one product. So this is your reaction. The enzyme facilitates the reaction and it lets them join together or form the bond or whatever reaction is happening actually. So it makes it faster. It's faster for the enzyme to help doing the reaction. So the enzyme here works as a catalyst. It increases the rate. Now, the other material is the inhibitor. Now, inhibitors are completely opposite to catalysts. Inhibitors are materials used to decrease the rate of the reaction. Let's check this example. For example, you know that in food they use preservatives and food additives to store the food for extra time. What does it actually do? It decreases the rate of decay. It decreases the rate of the reaction inside, or the rotting, or whatever is happening inside. If you can see here, these are 2 inhibitors, mold inhibitor and antioxidants. They are used to preserve food. They are used as additives in food. So they are labeled as inhibitors. So what are the 4 factors that we have seen till now? We have surface area, we have temperature, concentration, and the 4th one is catalysts and inhibitors. Actually, we care about catalysts more than inhibitors. So guys, this is the end of the presentation. Please solve the following. Pages 186, 187, all the questions on these 2 pages. Thank you and have a good day.